Today is Group 7 presentation. Our project is about the third runway surface of Hong Kong Airport. This is the project background. Hong Kong Airport's third runway system officially commenced operation on November 28, 2024. This section is about the new construction project. This section is about the impact of the new airport on Hong Kong. Our project is for the pavement engineering of the third runway, the north runway, 3,800 meters long and 60 meters wide in the three-runway system of Hong Kong Airport. This part is about the selection of materials and mechanical equipment. This section identifies the main materials and the supporting materials. The main materials are classified into 4 types: surface layer material, base material, laying material, and soil improvement materials. And the specification and the models are determined. This section specifies the construction equipment of their device type, specification, and quantity. The specific information about them is displayed in the table. This part is important for the report. It laid the foundation for the subsequent work. The construction process is divided into following 6 steps. The first step is construction preparation phase. Technical drawing preparation, on-site preparation, and document processing. The second step is soil foundation treatment. Construction is carried out using a dynamic compaction machine in 3 phases. The third step is subgrade construction. Continuous paving is done using a paver with manual assistance for leveling. The fourth step is grassroots construction. It's divided into 4 steps: mixture mixing, paving, compaction, and inspection. The fifth step is surface layer construction. It's divided into 3 steps: formwork installation, compaction, and joint construction. The final step is maintenance and protection of finished products. Curing of the asphalt surface layer and complete protection of the pavement sections. The specific detailed construction methods are clearly stated in the report.
Okay, this is my part: construction schedule and the project control. Just as in the previous construction process, to enhance work efficiency, we adopt the fold floor operation method, dividing the runway into 4 sections. The picture shows all the detailed processes of the project, and the AON diagram was drawn based on the project process in the table. And the yellow part represents the critical paths. This slide is about calculating probabilistic activity times. By using the formulas provided, we can determine that data is greater than 5. Referring to the table, we can know that the probability of the project being completed on time is almost 100%. And this slide is about construction schedule optimization. We set a checkpoint at the 90th day. At that time, M1 was just completed, so the SV was 8 days. Then we calculated SPI and EAC, and finally determined that the variance at completion VAC was 26 days. After that, we optimized the project following M1. And the slide first calculates the slope of each activity through a table and the formulas. The next uses the minimum value calculation formula obtained from the previous slide and the number of days that can be optimized. For example, if YP is less than or equal to 5, it can be optimized by up to 5 days. Based on the previous content, we can list the inequalities and issue that all x and y are greater than or equal to 0. And this slide shows the results from the Lingo software. For instance, at YQ, the value is 5, meaning it was accelerated by 5 days. And the final objective value is 1,230,000 Hong Kong dollars. Okay, that's all.
Next, I will be responsible for explaining how to reduce the project duration by resequencing tasks with minimal to no additional construction costs. Compress the critical path duration by resequencing tasks while incurring almost no additional cost. First, during the later stages of mixing plate AE installation, utilize the partially commissioned production capacity to manufacture a small amount of mix in advance. Second, once the specific length of the base course in Zone ZE is completed and accepted, begin the surface course construction in that completed section immediately. This enables the base and surface course teams to work in the flow sequence within the same area, reducing technical waiting times. The modified project schedule relationship table is shown in the figure. As you can see, the 7-day cushion layer carrying task has been removed, and the activity Z2 area base course paving has been subdivided into 2 segments. This approach not only shortens the project duration by 27 days, but also incurs minimal additional cost. The duration of the optimized critical path is 235 working days. This is a complete work breakdown structure and an updated Gantt chart reflecting the optimized schedule. Subsequently, I conducted a risk and probability analysis of the critical activities within this optimized plan. Calculations resulted in a z-value significantly greater than 5, confirming the optimized plan is highly reliable.
Now turn to my part, and my part is cost estimation and optimization, and this is my name and my net ID number. In my part, I will calculate the material cost, and the material cost can be summed up as this text table. My calculation method is made a rough calculation based on the material quantities and market pieces. The main materials needed to the runway structure include dynamic compaction treatment, glared crushed stone cushion, form a soil cushion, and these other materials will be used to make our project. And our material cost need to follow these 4 core ideas. And the first is the basic estimation logic, and the second is the optimization method, and third is the optimization dimensions, and the fourth is the core objective. After doing the calculation work, we find the total direct material cost is about 108 million Hong Kong dollars, and the key factor of equipment cost optimization is clamping and function treatment equipment, alpha mixing stations, spill form pavers, and other key equipment. The details can be summed up as a follow table. And the next part, we need to calculate the facility. Facility can be summed up in two parts: the new gender vs used gender and rent or buying. My part is doing the calculation between new gender and the used gender. At first, I calculate the double steel wheels roller. It's about weight is 13 tons, and we also need 6 units of this facility. We doing the calculation similar to exercise question 2 in our class, and this is the details of the calculation method. And when after calculation, we find the new gender is better. About 6 facilities will save about these Hong Kong dollar monies. And the facility of tire roller and the dynamic compaction machine is similar to the first facility, and this is our conclusion about these facilities, and the price as same as screen. After calculation, we find the new equipment has a significant advantages in present value of cost, with longer service life and more controllable maintenance costs. The second is the 3 types of equipment save a total of approximately 2.49 million in present value cost, providing a core economic basis for equipment configuration decisions.
Hello everyone, today I would like to discuss how we can use the present value method to decide whether we should purchase or lease the key equipment for the Hong Kong Airport third runway project. The duration of this project is 9 months. We assume the monthly interest rate to be 1%, so the discount factor can be obtained from the table. Our goal is to reduce the equipment costs. Firstly, regarding the asphalt mixing station, according to the present value formula, the purchase cost is about 2.73 million Hong Kong dollars. If opting for leasing, the rent is 1,600 Hong Kong dollars per hour, and the present value of the rent is about 3.29 million Hong Kong dollars. Therefore, purchasing the asphalt mixing station saves about 560,000 Hong Kong dollars compared to leasing. Secondly, for the sliding type paver, we need 4 units. The present value of the purchase plan is about 7.27 million Hong Kong dollars. If we lease 4 pavers, the present value of the rent is about 8.22 million Hong Kong dollars. In this case, purchasing can save about 950,000 Hong Kong dollars. In conclusion, for these 2 devices, purchasing is more cost-effective than leasing. The present value method provides a clear quantitative basis for equipment decisions and help us optimize equipment costs. Thanks.